Up on our list, Roman numeral 3, will be the beautiful gemstone Tanzanite. There's an example of Tanzanite over here on the right, showing this classic blue color that's very coveted. The story of Tanzanite is pretty incredible. It was only discovered in 1967, but it's now December's birthstone. So it has had a rapid rise to fame. It was discovered in 1967 by the Maasai tribesmen in Kenya under the shadow of Mount Kilimanjaro. They had found some blue crystals weathering out of the Earth's surface, and they really hoped that it was sapphire. Well, upon further study, they found that it's not. Instead, it was a mineral called zoisite, and it was this blue zoisite. So under A, let's just, okay, so, oh no, I'm jumping ahead of myself. You know what A is going to be, right? A is going to be mineralogy and geologic source. But right now, I was in the midst of a story about how we discovered this gemstone. Well, there was a problem because the actual mineral that it is blue zoisite. And no one wants to have zoisite jewelry. In fact, Tiffany's, when they were trying to market it, they were like, no, someone's going to say blue suicide, not blue zoisite. So that name is totally not going to work. And so they changed the name, Tiffany's did, to be Tanzanite, to be this alluring, exotic location named after the area of the world where it was found. It took off very quickly as a popular gemstone because of, let's put Tiffany's here because they were part of this story. And then let's also put sapphire replacement because the price of sapphire has gone up and down over the years. And when sapphire was too expensive before a lot of discoveries in Africa, people could get blue color they liked with this gemstone Tanzanite. So it's really a mineral called zoisite, and that's part of the more famous mineral that's like zoisite is epidote, and that is way too deep for an intro gemology class, but it'd be important for geologists in the group. The composition of zoisite is a calcium aluminum silicate, calcium aluminum silica, oxygen, and then OH. So it's water bearing. There's 12 O's. How many silicas are there? There are 3. There are 3 aluminums and there are 2 calciums. So that's our chemical formula. Mineralogically, it's actually really soft. On Mohs scale, it is a 6.5, which means it's softer than quartz. And that's going to affect our geologic occurrence because if something's softer than quartz, then when it gets into a river and there's all that quartz and gravel and cobbles everywhere, it's going to get busted and broken apart. So our geologic occurrence is not alluvial because of how soft it is. And the other thing is it has one prominent cleavage that makes it break apart pretty readily. So in terms of a gemstone, this guy is valuable because of that blue color. Blue is good. How can you draw a thumbs up really fast? I don't know. So blue is good, but the part that's bad is actually most of the mineralogical properties. It's very soft, and that makes it less good for things like rings and better for earrings and for necklaces. The specific gravity is very high. So let's go specific gravity. It's 3.35. So that's much higher than quartz. So you'd think it would be good to find in plasters, but it's just too soft. So what I'm getting at here is that the mining must be hard rock. And hard rock mining means you're going down to the actual source. And so you're like mine shafts is kind of the idea about what to picture when people are mining Tanzanite. And it's really only coming from this one place in Africa. The geologic occurrence, well, it occurs in these little pods and lenses in metamorphic rocks. So let's say it occurs in lenses, so small kind of pockets, maybe less than the size of your computer monitor to the size of a golf ball. That's kind of the size of the lenses that are occurring. And so occur in lenses in retrograde metamorphic rocks. In fact, we can get more complicated than that. Metamorphic carbonates. Carbonates are rocks like limestone. carbonate, like limestone, that then got metamorphosed in some mountain building collisional event, turns into marble, and then as that marble starts to go back up to the Earth's surface, oh, am I getting too complicated here? All right, so we're going to have a mountain building event. The actual mountain building event is called the East African orogeny, and it occurred around 600 million years ago. It's kind of interesting, right? That's a long time ago, where two plates are colliding into one another, creating a mountain range. Here's the suture zone between the two plates. Well, let's say our carbonates get pulled down to the depths of the mountain right in here, right? Deep, deep in the Earth's crust. And then, through time, the mountain range erodes away, right? And so the new surface of the Earth is like here. Well, this path going from deeper in the Earth when it used to be under mountains to where it's closer to their surface because of erosion is called retrograde metamorphism. So that's not the best sketch for it ever, but maybe you get the point. Our next point of this lecture is going to be color and optics. There's some interesting phenomena that happen with Tanzanite. Color and optics. Let's start off with color. Vivid blue and purple is what has value. Vivid blue to purple is where you're actually going to make money with sales and what you'd want to buy. Here's our top grade material from our Omi Privé website. But that's not the color that it comes out of the ground as. In fact, natural zoisite, so we're going to put this, how about this? Natural? No. Natural stuff, the natural material is usually brown. Natural material is brown. It's sometimes colorless. Sometimes it can be green. There's a whole jewelry trade built on this green stuff where there's, can we draw it? We can draw it. Where you get these green chunks and they carve it into beautiful shapes, and inside of the green there are these like kind of poor quality rubies. So if you ever see that and it's called like green zoisite, well, it's somewhat related to, well, it's green Tanzanite. So if this is what's natural, how are we getting these vivid blues and purples? And I thought I already told you, well, yeah, I did, that the first crystals I ever found were blue, just weathering out of the Earth. So there's an interesting problem here. What scientists have found is that heat treating takes these natural colors, we'll put it here, heat treating turns natural colors, ugly colors, largely, to purple and blue. I can prove it to you. Here's a figure from the Gemological Institute of America showing an experiment where they have taken material straight from the ground, kind of a brown orangey color, heated it to around 650 degrees C. All right, so moderately hot, and you can get this to change to that color, because what you're doing is you're changing, what are you changing? I think it's the valence state of, yeah, the valence state of vanadium, of trace vanadium changes. Is that the symbol for vanadium? Ooh, vanadium. Let's just write it out because I'm uncertain. But the first stones ever found were already blue. How could that have happened? Well, the actual idea right now is that there was a wildfire in the grasslands of Africa. Wildfires in the grassland. And people actually speculate that the wildfire occurred in 1967 when a bolt of lightning hit the ground. And then just shortly thereafter, the herders working cattle in the region found these blue stones that were naturally colored. Because heating turns it such a beautiful color and we can't expect natural fires to do it everywhere, this brown material is always changed to blue by man. And so what we're going to put here is that 95% of Tanzanite on the market is naturally heated, is man-made heated. What am I trying to say here? Is heated by man. That's the better way to say it. It's accepted by the community. In fact, they have this elegant way of saying, they say, removing the brown veil, trying to make that elegant. Really, all they're doing is trying to make it pretty so people will buy it. But marketing has been everything with Tanzanite. Of all gemstones, it and diamond probably have the best marketing story. The last thing to talk about with Tanzanite is its color and how it's not just blue or purple, it is pleochroic, which means it has multiple colors. And we'll say that Tanzanite is strongly pleochroic. And that means when you look along different crystallographic axes, the A axis, the B axis, or the C axis, you should see different colors. So here we go. Here's an image, again from GIA. They just had fantastic resource on Tanzanite. There's a crystal. This crystal here is the same crystal as this one. It's just been rotated by like 90 degrees. So here we are looking along, let's say, the A axis, and here we're looking along the B axis, right? The C axis would be coming out the top. And so if you look along the different axes, here we see strong purple, and here we see blue, but then you also see some teal coming out of the rock, okay? So this is what we mean by pleochroism. And you can see it even with the naked eye. It's one of the only gems that you can see it so strongly. What we'll say here is that crystallographic axis controls color. That'll be the first thing we say. We can put a little 1 here, an arrow. And we always want to make the most strong blue color the one we see with our gemstone. So if we were to facet, we would try to facet the gemstone to capture this blue here and not this purple, because it's that blue that will sell much better. In the type of colors that you're going to get initially are going to be brown. They say burgundy. What is that, like a dark red? There can be purple, teal, and blue, just depending on the stone. And we could play this game called Pick 3. Pick 3, because it is not just pleochroic, it's trichroic. So there's 3 different colors that can be seen. 3 colors can be seen. After we heat this to get it even to a better color, heating actually takes that trichroic and turns it into dichroic. And so we'll just have this be our last note here, is that heating turns trichroic to dichroic. You end up losing one of the pleochroism directions. And that'd be one way to identify if your stone is completely natural or if it has been heat treated before. I think that's the end for Tanzanite. It's a beautiful one with a fairly low price and one of the more stunning colors that you can come across.